Alright, so let's go into part F, G, and H. Comet 67P is the target for Rosetta. The distance from Earth on the interval t is between 4 and 13 is given by this particular function. When will Rosetta intercept the comet? So we have our original, a Rosetta trajectory, and what we need to do is graph this as well and see where they intersect. So let's take a look. We put this other function directly into your calculator, so you can go back up to the original tab that you were working on, and then menu 31 will allow you to type into a new function. So negative 33.1 x squared plus 440x, and then plus 78.1. Okay. So we can see they kind of start out very similarly. They break apart, and then they intercept each other right here. And what's interesting about that is we know that it's going to be between, it's going to happen between 4 and 13, somewhere in there. So we can see that right here. What we want to do, though, is find that intersection point. So you're going to go to Menu, and then you want to analyze your graph, and then find the intersection. This is 4. And we'll find it. There we go, right there. And so there's our coordinate point, comes up. And this happens at 10.410 years. 10.410 is where we can see that. Okay. So this is the x value of the coordinate point. And we are going to write our sentence. Again, on the x side, this is Rosetta intercepts comet 67P at 10.410 years since 2004. Alright. The belt is a region that begins approximately 4,500 million kilometers away from Earth. What is the closest that comet 67P gets to that belt over the interval between 4 and 13? Okay. So we know that the distance is 4,500. So we're going to figure out how far away the comet comes to the asteroid belt that's out here. So we need to know this maximum height, the y value of the maximum height, because we already know that this is 4,500. So what is this maximum height? So let's go back in, and what I'm going to do at this point, because I'm going to have to regraph anyways, I'm going to go to Menu, and I'm going to go to just add in a new document. I'm going to clear everything out and add in a graph so you can see that again. The graph I'm going to add in is the original, is the function of the comet. So negative 33.1 x squared, and then plus 440 x plus 78.1. Again, it doesn't come out, so you need to go to Menu. You can go to Window, Zoom Fits, and it makes that a little bit better for us. I'm going to grab this and just drag it down here so we can see a little better. Alright, so then we're going to add in our new line. We're going to enter in a function at 4,500, y equals 4,500. So that's up here. So we can see the asteroid belt, and we can see the comet, and what we need to do is figure out how close that comet's actually going to come. So we need to find the maximum point. Menu, Window Zoom, and then, Analyze Graph, and then find that maximum. Alright, the maximum of this graph will happen right here. Okay. So at 6.65 for the x value, and that is 1,540. I'm just going to copy this coordinate point down. 6.65, comma 1540.336. Okay. So this is the maximum point of the comet, and we already know that this is at 4,500. So what's the difference between the asteroid belts and the maximum distance here? Alright, so let's take a look. We can go to Document, Insert, a calculator, and we'll type in 4,500 minus how far out the comet goes, 0.336, and that ends us up with 2959.664. So 2959.664. Now we need to decide which variable is this about. Is this talking about the time or the distance? And hopefully you've come to the conclusion what we're doing is talking about distance. So this is 2,959.664 million kilometers from Earth. So this is millions of kilometers. Okay. The very last one says that let's say that Rosetta stays on the comet after intercepting it. Write a function that gives a distance between them at any time. Alright, and then we're going to do a domain restriction here.